In this video, we're going to talk about cycloid and how to parameterize the cycloid. What is a cycloid? Is the curve traced out by a point P on the circumference of a circle as the circle rolls along a straight line. So assume that we have this circle and we have a point P, and we start rolling the circle on this straight line, and as the circle moves, the point P is gonna trace like this, like this curve. So the black curve in here would call cycloid. And now we're gonna write parametrization of that curve. So let me start by graphing x-axis, y-axis, and let me actually make it just a little bit bigger. I'm gonna move it in here, and then I'm gonna say that I have a circle, and I'm gonna put the circle in here. Okay, the circle has a center, the center C, and that's the radius, and assume that this is the point P, the point that we care about. This is the origin, and I'm gonna have this point in here, T. Okay, let's call this angle here theta to be the parameter for rotation of the circle. So it's parameter for rotation of the circle, and when theta is equal to 0, then P is on the origin. Okay, so based on this fact, we're gonna say that OT, this length in here, the length OT is equal to the length of PT, since just assume that the point P was in here, and then the circle starts to rotate, and that's why the point P goes a little bit up. That's why the key factor is that PT is equal to this angle in here, OT. So as a note, I'm gonna say that the length of OT would be the length of the arc PT. And what is the length of the arc PT in here? It would be, by simple geometry, it would be r theta, the radius times r. Why is that? It's just because this arc in here would be just the part of the whole circumference, and the whole circumference of the circle is 2 pi r. So when theta is equal to 2 pi, we get 2 pi r as the circumference of the circle. Now that we just have just a part, just one arc, and that arc would be r times theta. Okay, anyway, now I'm gonna say what is the coordinates of the point P. The point P in here, let me just move P actually. Oops. Nope. Okay, I'm not gonna move P. So P has x coordinate and y coordinate, and x coordinate would be just that. This is the x coordinate of the point P, and what is that? As you see, it would be OT minus P minus this part. Let me just have a right triangle in here, and I'm gonna call this one Q, and I'm gonna say that x coordinate of the point P would be OT minus the length of PQ. Okay, we said that OT is equal to r theta, so r theta minus, how about PQ? This in the right triangle it would be r sine theta, r sine theta. Perfect. How about y coordinate of the point? So y coordinate would be here, and it would be CT, the whole part in here, minus CQ, minus CQ. So CT is just the radius, which would be r, minus CQ in the right triangle that I have in here would be r cosine theta.